In algebra, there are 5 very commonly used exponent rules when we simplify expressions involving exponents. And in this video, I'm going to cover the first 3 rules, exponent rules involving multiplication. And to help you understand and hopefully you're going to be able to remember these 3 rules, we're going to look at these 3 examples. Now, at this moment, we don't know any rules yet. So when we solve this problem, x squared times x third, all we know is the definition of x squared. So if you remember from the previous video, x squared means the exponent 2 means 2 copies. And 2 copies multiply 2 copies of the base x. So 3 means x to the third means we multiply 3 copies of x. So we're going to expand then. So we have 2 copies of x here and 3 copies of x. So 2 copies here and 3 copies here. And notice that between the 2 pairs of parentheses, we also have multiplication. So since it's all multiplication, we can literally drop all the parentheses. So just pretty much you just get 2 and 3 all together. As you can see, this is multiplying 5 copies, and you can see we have 5 copies. And again, this 5 comes from 2 copies plus 3 copies. That gives us 5 copies. So that tells us whenever we multiply 5 copies of something, the same variable, and we can write this as x to the 5th. So this can be written as x to the 5th. And this phi, exponent phi, comes from adding 2 copies and 3 copies. And of course, we're doing multiplication, but we are only adding the exponents because the exponents tell us the number of copies we're multiplying. Okay, and so notice it's sort of like if you get 2 copies of x and then you have to multiply another 3 copies of x, and altogether put all the copies together, you get 2 plus 3 number of copies of x. So this gives us the first formula. X to the nth times x to the nth equals x to the n plus n. So this is the case when we add the exponents. And notice they both have the same base x. If one of them is y, we can't, because if you have y's, and you cannot really put them together, say we have 5 copies of x or 5 copies of y. So whenever we multiply them, we have to make sure they're both x's or both y's. So in this case, x just represents the same base. It could be both x, both y's, both a's, any letters. So we keep the base and x and add exponents. Keep the base and add exponents. Okay, now the second formula, you can look at the second example, x squared to the third. And the difference between this and the previous one is, in the previous case, we have this 3. Exponent 3 means 3 copies of x, so which can be written as x times x times x. But this 3, notice the base is inside a pair of parentheses. Again, treat it like a box. So it's not like 3 copies of x, it's 3 packages, and each package has x squared in there. As you can see, if you get all of them out, you have a total of 2 copy, 2 copy, and 2 copy. That's a total of 6 copies. So we're not adding 2 and 3, we're actually multiplying 2 and 3. And because the reason is we have 3 packages of 2, or you can say we have 3 2's. When we have 3 2's, and you can use the times table, you do 3 times 2. But again, 3 times 2 is the same as 2 times 3, so you're going to get 6. So this is how we do it. 3, because again, the base is in a package, in a pair of parentheses. So we have 3 copies of x squared, and x squared. And of course, we can do addition by using, adding 2 and 2 and 2, but it's much faster if we just do 3 2's or 2 times 3. So that gives us the answer 6. And be very careful about these 2 cases. In the first case, we add exponents, but in the second case, notice that here we multiply the exponents. Again, it's the difference is this 3 means 3 copies of x's, single x. See, there's no package, nothing, it's just a single letter x. But right here, it's like a package. So you have like a box, so you have x squared and squared, and if you multiply all of them, you literally like doing 3 2's. So here you 3 and 2's. So in the format, you can see this 3 is on top of 2, or were they right beside each other. So this is literally we're doing 3 2's. But this one, you get 3 x and 2 x's, then you combine them to get 5 copies. Okay, next let's look at the last case here. In the previous case, notice that we have 2 exponents. We either add them or multiply them. But in this case, we only have 1 exponent, which is 3. So what we have here in the base, it's in a pair of pencils. Again, it's in a box. In the box, we have x and y, and then x and y, and then x and y. So if you receive all of these, you can multiply all the x's together to get x to the third, 3 copies of x third. And when you multiply 3 copies of y, you get y third. So this is what we have here. Let me move this a little to the right. So you have xy, xy, and xy. And you just multiply all of these x's and all of these y's. So that will give you x third here and then y third there. Okay, so now we are going to look at the formula that, and this when you look at the answer, it's kind of x third, y third. It's sort of like you're distributing the exponent to both in the boxes in the box, so you get x third and y third. And in general, the exponent can be anything. So if you got a 4 here, you distribute 4 to both of them. If you got 5 here, you distribute 5 to both of them. So these are the 3 formulas, exponent rules involving exponents. So now we can look at a few examples here. These x fifth times x ninth. So now when we solve these questions, we are not going to use the definition, expand, write down so many copies. So we're going to just apply the formulas we learned. So again, same base, and we have 2 exponents. And in this case, we will add 5 and 9. Again, if you receive 5 copies of x, and then another 9 copies of x together, that's 5 plus 9, which is 14 copies of x. But in the second case, so here, again, it's 5 copies of x and times and 9 copies of x. So you're going to add, both are x's, so we add them, 5 and 9. But right here, this 9, notice this 9 is right next to 5. Right here, 9 is not next to 5. 9 is applied to x. But this 9 is applied to not x, it's applied to 5, the 5th exponent. So this is kind of what we said in the package. So we have 9 fives. When we have 9 fives, using the times table, we do 9 fives gives us 45. So that's multiplication. Now the last case, we only have 1 exponent, but in the box we have xy. So we distribute exponent to both of them to get x 20th and y 20th.